Okay, let's do this metric conversion worksheet. Let's put our names at the top. And this is Biology 143, and it's the lab of the metric system. And so what we want to do for this is, first of all, we want to look down here at this chart. And the first thing we want to do is orient ourselves with the main. And the main would be if there is no prefix to the unit. So what I mean by that is, if you look at this L right here, this L has no prefix. It's just the L. Also, this G right here has no prefix. It's just the G. The L stands for liter. The G stands for gram. On the other hand, when you look at this double M right here, well, this does have a prefix. There's the M in front and there's the M after. So the prefix is milli, right, which we can see right here is the milli, and the second M is meter, so it's millimeter in this case. Okay, so that's what we want to do to figure this out. The same thing over here, if we were to look at on this side, the kg, right? The K is the prefix and the G is the unit, so it would be kilo. Kilo is the K, and gram, kilogram. And the easiest way to do this is to realize that the units on this side are larger and the units on this side are bigger. And we always want to look for the decimal point, and then we literally just jump in the direction that we want to go. So the best way to do it is just to start, and as we go along, you'll get the idea. So the first question is 36.52 milligrams equals how many grams? Now remember that grams is going to be the main because it has no prefix. And over here we have milli, so we're going to be on this side milli. Now to get to grams, we got to jump in order to get to grams, to get to the main. So let me show you how to do that. I'm just going to write it on the side right here. 36.52, and I'm going to find the decimal point, and I know that I'm milligrams and I got to get to grams. So how many times do I have to jump? Here we go. 1, 2, 3. That's 3 jumps to get to the main. All right, so let's find the decimal. 1, 2, and 3. And we stick our new decimal right there where we stopped. And notice we have a loop that's empty, so we have to fill it in with a 0. And I like to always put a 0 in front of the decimal if there's nothing in front of it. You don't have to, but I prefer that. In terms of style, it just looks better to me and more clear. So now I know that the answer is going to be 0.03652 grams. Let's do the second one. For the second one, we have kilograms and we want to go to milligrams. So we have kilo on this side and milli is all the way on this side. So let's write it out on the side here. I've got 14.72, and I need to jump 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I got to fill in my loops that are empty. I put my decimal where it ends. And now I know that I'm going to have as an answer 14.720000. And I can even put a period or a decimal point 0 to show that that's the end of it right there. And so let's see if we put some commas to see what this actually is. So 3 zeros there, that's a comma. another 3 numbers there, that's a comma. So 14,720,000 milligrams equals 14.72 kilograms. Now hopefully this makes sense to you. Kilograms are huge because kilo is big. Milligrams are tiny because milli is really small. And so, of course, if you're going to talk about something small, you're going to have a lot of small things equaling a large thing. Okay, let's go to the next one. So we have 0.0035, and we are at the hectometer. So the hectometer is right here, and we want to go to the decimeter. And so we want to jump 1, 2, 3. Okay, so find the decimal. 1, 2, 3. Put the new decimal where we stop. And in this case, we don't have to fill in anything with zeros. So notice that this is just 3.5. 3.5. Next, 0.134 meters. And we want to go to kilometers, or oftentimes we say kilometers. And so meters is just our main because there's no prefix. And so we start here and we go to kilo. Now notice we got to go backwards. So look, 1, 2, and 3. So 1, 2, and 3. Fill in the zeros, put the new decimal. And now what we have is that we have 0.000134 kilometers is equal to 0.134 meters. Next, millimeters to centimeters, just one jump. Okay, so if you can just see it, then you don't have to write it out all over again. So in this case, I can just look at it and tell, because it's just one jump, it's pretty easy. So in this case, I go one jump in that direction. So I know my decimal's here, I just go one jump, I just imagine it right there, so it's 2.5. Okay. Let's look at the next one. We've got 2.5 centimeters cubed goes to milliliters. Oh my goodness, what do we do here? We've got meters and liters. Well, the thing to remember here is that when we take a cube, and a cube is a three-dimensional object with length, width, and height, those 3 dimensions, if I put 1 centimeter for each of those dimensions, I need to multiply them together in order to get the overall volume. So in this case, if I multiply 1, that's the height, times 1, that's the width. I'll put this one right here. Times 1, that is the depth, then I end up getting 1 centimeter cubed. But 1 centimeter cubed is actually equal to 1 milliliter. And so basically what we're doing is, this is kind of a trick question right here. They're trying to see if you know that centimeter cubes are exactly the same as milliliters. So guess what? Over here, it's just 2.5. In other words, nothing changes because centimeter cubed and milliliters are the exact same thing because of this drawing I have over here on the right side. So 2.5 centimeters cubed equals 2.5 milliliters. Okay, this dA here, kind of an interesting prefix. That one is deca. Now notice it's dA because we also have deci. And so they've got 2 here that start with a D. And so they had to make them different from each other. So they took that A right there. They put the dA to make a deca. So we got 243 decaliters to liters. So basically we're going from deca to the main, that's just one jump. We find our decimal, we jump once, we fill in the 0. So that would be 2,430 would be the answer. Okay, next, from liter to milliliter. And so we're at the main, we're at the liter, and we want to go to milliliter. In this case, let's see, 1, 2, 3, and 4 jumps. Can you just use your imagination? Let's see, 1, 2, 3, 4. Those would be 2 zeros that I'd have to fill in. 45, 2, 3, and then 2 more zeros, right? So if I put my commas, I can tell what this actually is. This is 4,500,000. Oops, I'm sorry. That's a mistake right there. So it's 452,300 milliliters. Okay, next we've got hectoliters to centiliters. And so in this case, we have to jump 1, 2, 3, 4 times. So let's see if we can just use our imagination. 1, 2, 3, and 1 more 4. We can imagine a 0 right there. So that would be 350. Okay, next, millimeters to meters. Millimeters to meters. So we're here, and we got to go there. Okay, so we got to jump 1, 2, and 3. So we got to jump in this direction, right? 1, 2, and 3. We put our 0 right there, and we put our new decimal in front of that 0, right? So 0.02732. All right, next, 15 meters to just the 1D, so that's decimeters. So we're from the main, and then we go to deci. So it's just one jump. So there's our decimal. We just go jump once. So we just basically add a 0, 150. Next, we have centi, and this centi right here is going to be this is another trick question. They want to make sure that you know what that double C is. So double C stands for cubic centimeter. And so basically that's the same thing as cm cubed. But we know that cm cubed is also the same thing as ml. So that would also be the same as ml. You see how I got there? Okay, so just replace ml right here. If you replace ml right here, it becomes very easy. It's basically milliliter to liter. So we go from milli to the main. Okay, so we jump 1, 2, and 3 times. So 1, 2, and 3. We put in our zeros, we put in our new decimal, and we have 0.000, another 0, 2, 3. And that makes sense because the liter is big and the milliliter is small. So you have very little of something big equaling a little bit of something small. Okay, let's go from kilometers to millimeters. So we're on this side kilo, and we have to go all the way to there for milli. So we got to jump 1, 2, 3, 4, 5, 6. And so let's see how that would work. We're going to go 1, 2, 3, 4, 5, and then one more 6. So I would end up putting a 0 right there. And I would have a decimal right after that. So that would be 490. Okay, next. 0.025 kilograms to grams. So I'm at kilo, and I want to go to the main. So that's 1, 2, and 3. So pretty easy. 1, 2, 3. There's my new decimal. 25. 15 grams to hectograms. So I'm at the main, and I got to go to hecto. So 1, 2. Okay, so there's my decimal. So I go 1 and 2. And there's my new decimal. So it would be 0.15 hectograms. The next topic is the topic of density and how it relates to mass and to volume. The way that we depict density is with this Greek letter rho. That stands for density. And we use the letter M for mass and the letter V for volume. And the main equation is that density, or rho, is equal to mass divided by volume. But we can manipulate this equation and change it around. So for example, I can take the volume and bring it to this side and stick the rho under the mass. And so I can get a new equation from this that basically says that volume is equal to mass over density. And furthermore, a third equation I can derive is that I can, from here, starting with this one again, I can figure out that mass is going to be equal to rho times volume, right? Because I can take this V and bring it to the other side, but if I do, I need to multiply it by the rho. And so these are the three equations that we're going to use for the following word problems. And once you know these, it's pretty easy. Here's a triangle that some individuals find helpful, where basically over here it says that the density, or the rho, is equal to mass over volume, right? You can see that the mass is on top of the volume in this triangle diagram. Also, volume, or V, is equal to mass over rho, okay, so you can look at it that way. And the third way to look at it is that mass, or M, is equal to rho times V, because you see that they're right next to each other, so that would be multiplication. So this triangle can help. If it does, please go ahead and use it. So let's go ahead and start. If you have a density of 3 grams per milliliters and a mass of 15 grams, what is the volume? Okay, let's use these equations. So we want to find the volume equation because that's what we're solving for. So V is equal to mass over density. And they tell us that the mass is 15 grams, so that is equal to 15. And always put the units for these. So put the G right there. Trust me, do that, because if not, you're going to get confused. 15 grams over the rho, or the density, is 3 grams per milliliters. And so what happens is that the grams cancel, and so that you're left with milliliters, which is what you want, because milliliters is a unit for volume. And so then you simply do 15 divided by 3. We know that 15 divided by 3 is just 5. So the answer is 5 milliliters. Next, if you have a density of 3 grams per milliliter and a volume of 10 milliliters, what is the mass? So now we want to solve for mass, so we're looking at this equation. So M equals rho times volume. Okay, so that's going to be, the rho is 3 grams per milliliter times the volume of 10 milliliter. And always put the units, because that's how you're going to see what cancels out. So the mLs cancel, and you're left with the grams. And so now you just do 3 times 10 is 30 grams. Okay, let's look at the next one. if you have a volume of 10 milliliters and a mass of 100 kilograms, what is the density? So now we're solving for rho. And so rho is equal to mass over volume, and that is going to be 100 kilograms over volume 10 ml. Okay, so now it's going to be 100 divided by 10. So the easiest thing to do here is just to cross out the zeros, right? So if you cross 1 out on the numerator, you cross 1 out on the denominator, and you end up with 10. And for density, the units are going to be the mass per volume, okay? So don't be confused by that. For density, you're going to end up having a unit that's actually going to be 2 units on top of each other. So it's kg per ml. Next, if you have a mass of 50 grams and a density of 2 grams per milliliter, what is the volume? Okay, so we want to find volume is equal to, we look at our equations down here, is going to be mass over density. And we have 50 grams divided by 2 grams per milliliters. The grams cancel, and we just do 50 divided by 2, which is 25. 25 milliliters. There we go. Next, you have a volume of 5 liters. I'm sorry, 55 liters, and a density of 2 kilograms per liter. What is the mass? So we want to find mass. Mass is equal to density times volume. Okay, so we're going to put density is 2 kg per L times volume is 55 L. The L's cancel. Here we have to multiply, so 2 times 55 is equal to 110. And we're left with kilograms. Next, you have a density of 15 grams per milliliter and a mass of 5 grams. What is the volume? Don't use fractions, change it to decimal form. Okay, we can do that. So, what is the volume? Volume is equal to mass over density. So the mass in this case is 5 grams. The density is 15 grams per milliliter. And so the grams cancel, and this is why they say use decimal form, because it would be easy to just say, okay, 5 over 15 is the same as 1 over 3, right? You see how I did that? If I divide 5 by 5, I get 1. If I divide 15 by 5, I get 3. And then I'm left with milliliters. So that's the fraction, but they say don't use fractions. Change it to a decimal form. So you can use a calculator, but you should also know that 1/3 is 0.33 that kind of repeats forever. Okay, so that would be your answer, ml. And it's a good thing to know that 1/3 is equal to that. Okay, so next we've got a volume of 8 liters and a mass of 16 kilograms. What is the density? So we've got density rho is equal to mass over volume, and we've got the mass is 16 kilograms and the volume is 8 liters. This is pretty easy. 16 divided by 8 is 2. And remember that the units for density have these 2 units, one on top of another. So kg over L. Next, you have a density of 2.5 grams per milliliter and a mass of 5 grams. What is the volume? Volume is equal to mass over density. So mass is equal to 5 grams. Density is equal to 2.5 grams per milliliter. The grams cancel. And what is 5 divided by 2.5? Well, 2.5 goes into 5 twice, right? So it would just be 2 ml. And here we go, almost the end here. So if you have a density of 100 kg over L and a mass of 1,000 units, tell me the following. First, what are the mass units? Well, they give us the mass units right there. It's kg. Okay, so what are the mass units? Kg, right? Because this is the mass. So they're just making sure that you understand that that density right there is referring to a mass over volume. Okay, and so that's the mass unit, right? Pretty simple. Secondly, what is the volume? Okay, so volume is equal to mass over density. And so what we have is 1,000 kg, right? We figured out it was kg, divided by 100 kg over L. The kg's cancel. And now we just cross out our zeros. If I cross out 2 zeros down here, I'm going to cross out 2 zeros up there. So I'm left with 10. So the answer is 10 liters.